The Andromeda Galaxy is approximately 2.5 million light-years away. This means it took light from this galaxy 2.5 million years to reach us, traveling at about 300 million meters per second. But how could we possibly have measured such an enormous distance? One way astronomers figure out distance in space is parallax. This effect can be modeled by holding your finger a few inches in front of your face, and looking at it first with one eye closed and then with the other eye closed. You'll notice that it seems to change position. This effect occurs because each of your eyes are viewing the finger from a different angle. The same thing happens as the Earth orbits the Sun. We can view a star at one point in Earth's orbit, and then again 6 months later on the other side of the Sun, giving us a different viewing angle. By measuring how much the star appears to move across the sky, we can calculate the parallax angle. And, since we already know the distance from the Earth to the Sun, all it takes is a little right triangle trig to find the distance to the star. But this technique only works with stars that are about 400 light-years away or closer. Beyond that, the star's movement due to parallax is just way too small to measure. To measure even further out, we'll have to take a closer look at the star's brightness. When we look up at the stars, what we see is their apparent brightness, or how bright they appear to us. However, apparent brightness depends on how far away the star is. Think of a flashlight. If your friend is holding the flashlight a few feet away from you, it definitely doesn't appear as bright as it would if you were holding it a few inches in front of your face. So, a really bright star can appear dim to us if it's extremely far away, and a relatively dim star can appear bright if it's close to us. This is important because if we know both the actual and apparent brightness, we can use the relationship between them to calculate the distance to the star. So that means to find the distance to faraway stars, we need to figure out what their actual brightness is. This can be done with a special type of star known as Cepheid variables. Cepheids are a type of star that pulse like a heartbeat by expanding and contracting with a uniform interval of time. Scientists gathered data on the actual brightness of many nearby Cepheids, using apparent brightness and distance as determined by parallax. Then, in the early 1900s, astronomer Henrietta Swan Leavitt noticed that brighter Cepheids pulse more slowly, which is called the period-luminosity relation. This relationship allows scientists to find the actual brightness of any Cepheid using the length of time it takes to pulse, without needing parallax to measure the distance to the star. Then, because they know the actual brightness and the apparent brightness, they can calculate the distance to the Cepheid. So, how did all of this help us figure out that the Andromeda Galaxy is 2.5 million light-years away? To recap, scientists used Cepheids with a known distance from us, which was calculated using parallax, to establish the period-luminosity relation, which allows us to figure out how far away any Cepheid variable is. And because some of the Andromeda Galaxy's estimated 1 trillion stars are Cepheid variables, we can use these distances to figure out the distance to a whole different galaxy.